Hey, it's Lucas. Got a new machine here at Bridgeport. It's a J-head mill from 1967. It's in really good condition, and it's got a lot of bells and whistles on it. In fact, I think it's got just about everything on it that I'd put on it if I were going to use it. Got a step pulley system in it and a variable speed frequency drive right here. And the VFD is great. It's a nice feature. There's ways to program all kinds of things in it, the ramp up speed, braking, all of that. It's all actually pretty intuitive. Got manuals for all this. A couple things I just want to show on it right off the bat are the spindle and the DROs. So there's the DRO. So here's our x-axis. I'm not sure if you can see the display incrementing, and the Y. Set up right now for thousandths resolution. So what I want to do is just show some of the condition aspects of this mill. So first we're going to take a look at the table, and this table's really for a machine of this age, it's really in great shape. I do see where some things have occurred over the years. There's some holes in it, but they're very minor. They're really not an issue. Here's a few of them. It's got a few scratches and gouges, but it's all nice and flat in terms of there's no high spots on it. What I'm going to do next is take a look at it with a straight edge, and I've got this as a Mitutoyo feeler gauge. It's 2/1000 thick, and I've got a blue point, so it's a it's a snap-on straight edge. It's a 3-footer. And I'm going to lay this on here, and actually I don't see any sag in the table, which is quite remarkable. I'm going to show another little test here in a moment, but first we're going to do, we're going to set this on here. We're going to take this 2/1000 feeler gauge now and put it in. In particular, I'm looking for a high spot in the middle because these tables sometimes will sag with time. This one does not seem to have that problem. So first test. So 2/1000 gauge, I'm going to put it here, and it's pulling. In other words, we've got compression between the straight edge and the table at the far end, and about the same compression in the middle, and at this end it's about the same compression. So we're feeling tension on the blade as we pull it out from under that that compression. Now I want to show a little different method of checking the same thing. So this is a piece of paper. It's doubled up, and it's 7.5 thousandths thick. Actually, it's coming in at 7 thousandths there. Okay, so what I'm going to do is put this under the straight edge, and then I'm going to run this 2/1000ths down along here. We'll see just how, at least it'll tell us how symmetrical this is. I'm going to scoot this down just a little bit so it's so you can see I'm right out at the edge. Again, a 3-foot straight edge. So we can slip this 2/1000ths in there. That's not a big surprise because it's almost 4 times as thick as this. But we're starting way down here now, over halfway, which is just about where we want to see it. I can still move it, and it binds up right about there, which is ideally it should be. Because it's 7/1000ths and this is 2/1000ths, it should be about 2/7 from this end to that end, and it's not quite that. So it's pretty close, though. It's probably it's within 10 inches of the end here. So I'm going to flip it around. I'm going to put the same shim down at that end and kind of run this feeler gauge down the same way. And I've checked all all 4 of the bars, as it were, on the table, and they all seem about the same. So we're going to pop this down here now, and here's again our 2/1000ths feeler gauge, and running that right down. I'm just going to grab the far end here, and it's binding up right there. It's about maybe 11 inches from the end, so it's very close to flat. This table's in really great shape. So that's just a way to demonstrate it. It's looking really good. Let's talk about some other parts of the mill. I want to. Okay, I've just had to remove the camera from the tripod to demonstrate this, but Here we've got the flaking on the y-axis, so and on the knee. You can see what kind of condition this is in. It's had this nice swarf guard on here. I'm not certain how long, but it certainly looks like it's done its job. Some other features of the mill. Some of the things it's got with it. This is a nice feature. It's a one-shot oiler for the knee, and I believe for the both the X and Y. It looks like it distributes right there into, oh gosh, 7 channels probably. So it's got an oiler, and I pumped it a few times yesterday, and I'm seeing a little oil come down here. So that indicates to me that at least that oil groove is okay. The lead screw looks phenomenal, and there's not a lot of lash in the X. Not a lot of backlash. Let's take a look here. Here's the little chamber. You can store documentation in there, and in fact we had documentation in there, and I'll show some of that later. Here's the variable frequency drive. I'm going to fire this up. So you can hear how quiet this is. It's just terrifically quiet. We do not want to use that to reverse or shut off the motor. We want to use this one, because if you do use the external switch, these don't like that, and you may lose them. They may blow out. Here is a set of collets. I think there's 13 collets in the set. There's a drill chuck. There's this nice rack to hold them all. So there's 13 plus the drill chuck. It's an R8 spindle in the mill head, and it moves nicely. Everything works on it great. I'm going to show that next. This light does work. There's a work light here, and here's the DRO. So let's and I'm not seeing this one change, so I believe that there's a setting on there, and we can reset it and then start over again. So that's very nice. Same on the X or the Y axis. This can be reset and then redone. This is a Sony digital readout. It's a LF200. I'm not certain how old it is. It's got to be a little bit old. So anyway, that's the digital readout. What else? It's got this, the Traverse. So it's got a motor that's designed to actually engage the X-axis lead screw. So let's look at that. And it is a Bridgeport. There are stops that you can set up on it. If it hits a stop, it'll shut off, and you can also reverse it. So there it's going in reverse, and you can also rapidly traverse. So like I said, it's got many bells and whistles on it. Okay, so what I've done here is I've loosened up these 2 bolts. So once those are loose, you can move this very easily. It's nice and smooth. Everything works great on it. I think there's about, at least 6 inches of throw on it. Maybe a little more than that. So it's nice because it ends up giving you more effective work envelope. So it's a nice feature, and it's something that comes in handy. The turret, you loosen up these 4 bolts to rotate the turret. That I did not do. I did not open that up or clean it out. It's just the way it was when it came into the shop here. The nice thing is that the same 3/4 inch wrench fits all of these systems. So we'll loosen these up now, and we'll show the knotting aspect of the head. This is all under control of this bolt up here. So once you loosen the 3 locking bolts, this one actually will, now we're tilting the head up, so tilting it this way, and we can also bring it back and tip it down. And now it's, right about now, it's in negative territory. So it's another nice feature of the Bridgeport. You can also pivot the head this way, so twist it around the... So to tilt the head, that's how to tilt it or to knot it. There's also a way to rotate the head. That is to twist it this way, and one loosens these bolts. Okay, now to pivot the head this way, one loosens these 4 bolts, and then there's a screw to control the angle of the head right here. So that can be turned from 90 degrees. And that's actually another nice feature of this mill. Okay, now I'm going to show just the quietness of the spindle at the higher RPM. So now we've got the belt set at the highest speed. And I've got a little tachometer here. So here we go. It's coming up as 2,800 RPM. Just sounds phenomenal. No rattles, no noise whatsoever. Right here we're going to demonstrate the quill down feed, and this is a nice feature on this mill. I've got it on the highest speed. There's 3 speeds, and it just engages it like that. Kick it out. There's an automatic kick out on it too, right here on the quill. You can set it with these mechanical stops, but to get it to function that way, it works like that. Then it can also be reversed. I'm going to shut it off just because it's easier to pull this pin when it's off. So, all right, now it's in the reversing direction, and you can see it's going back up again. I believe you can actually adjust this there. It's doable either way while the machine is running. So, and that can also be switched from one speed to another on the fly. There's the slowest down feed. It looks like there's 6 thousandths per revolution, 3 thousandths, and then 1.5 thousandths per rev. All right, that's the Bridgeport mill. It's really a nice machine. I wish I had room for it in the stable here, but it's got to go. So somebody's going to love it. This is Lucas signing off.